Bert. I'm a staff machine learning engineer at PagerDuty, where I've been leading a lot of the work, setting up our PDAdvance, our generative AI solution, which includes our AI agent capabilities. So we have 3 agents that we've currently rolled out. Just go through them in order. The first one is the Insights agent. Now, one of the common problems when you want to know how your team is performing is you go to an analytics page and there's a wall of information, but that information isn't the information that you want. Instead, you want to ask a specific question. Rather than having to create more dashboards and trying to build a set of dashboards that meet everybody's use cases, we found that the Insights agent allows people to find the information they want in the format that they want. Then we also have the Shift agents. So a common problem we encounter with PagerDuty is you're on call. Right, when am I next on call? Who's going to cover me when I'm off call? How can I find coverage for my PTO coming up next week? The Shift agent supports with all of that. It looks at your on-call schedules, looks at your calendars through Google or Microsoft, and informs you have a conflict. You do have a conflict. It helps you find somebody to cover that conflict. Or if you want to find a replacement manually, you can ask it to look that up and to find your coverage. Both of those agents live within Slack. And so they're where we as engineers work. They're easy to access and easy to use. The third agent is the SRE agent. This agent is slightly different in that it's an agent to support you during an incident. So it brings together all of the information that we have about the incident that is ongoing and summarizes that for you. It ingests any runbooks that you have that you can provide it with and uses all of that information to provide recommendations of how you can resolve incidents. At the moment, that's living within our operations console. So when you're using that feature, you can see for an incident what your recommended next action is. We've looked at a number of other options, some of them for internal use cases, some for external use cases. Our primary focus, though, is on taking those 3 agents and making them better, going deeper on those rather than broader, getting all the knowledge that we can. We're ingesting more data sources, in particular into our SRE agent, where we believe there's a lot of scope to develop and improve that, to learn more from past incidents, and to build up a better set of knowledge for the agent to provide better, more proactive support going forwards. This was a very interesting question, and having thought about it, I would say the thing that's really we've come back to is the importance of critical user journeys and the value of agents in defining them, but once you've defined them, the importance of using them to define your agents. So you end up with this feedback loop. If you use your critical user journeys well, you can define an agent in a way that maximizes the performance against those. It's very easy to build a basic agent that can do everything reasonably well. But then you hit performance limitations. For example, in our Shift agent, a common question is, who can cover my next on-call shift? This is a critical user journey. The agent can solve that in a fully agentic way. But because we found this question coming up again and again and again, we were instead able to use a tool, to build a tool that is able to do that task on its own, making that aspect of the agent much faster, allowing us to provide a better experience for customers who believe that this is just an agent behind the scene doing the work. But in reality, we can replace that critical journey with a set of code that can answer those questions. So this is something that we're beginning to see happening in PagerDuty. When we started our journey into AI agents, we initially were experimenting them within a core AI first team. Very quickly, we decided we wanted to expand this to the whole business and educated all of engineering in what agents are and how to develop them. Now that the agents are being developed, we're encouraging our PMs to go into the platform, see what's going on, and look at how they can improve them and become active participants. This is an area that we're still early in our journey on, and we're currently working with the PMs to encourage them along that journey to provide a tighter and closer feedback loop. Evals are the way that you know what your agent is doing. Agents are a black box. You can fire off a question to it, it does something, and something comes out the end. The great thing about LLMs and the bad thing about LLMs is they will always give you an answer, and they will give you that answer in a way that makes you want to believe that answer. So you need to be able to check that the answer it is giving you is a good, useful answer. And for us, that is where evals come in. How we do the evals depends upon the agent. Some agents with golden data sets are absolutely the way to go. For example, our insights agent, we might have questions coming in for which we can extract the correct answer. So if I ask the question, how many incidents did I have yesterday? I can write an SQL query to extract that information. So we have a golden data set. The challenge with the eval, though, is I want to test the agent's ability to answer that question. How many incidents were there yesterday? Now, when I rerun that eval in a week's time, yesterday is a different day. So we have to update the golden data set using SQL queries as part of the evals process. So we have a living set of evals without a fixed golden data set. It's a fixed golden data set generating script that we use to produce those. For other aspects, a golden data set is more difficult, either because there is no defined answer, or because there's multiple possible ways of solving the problem, or because setting up a golden answer is just too difficult. It involves using production systems with production calendars and other things like that. There we find having LLM as a judge is far more valuable, where we can look at individual parts of the journey, score individual aspects of that correct, and combine those evals to see if the result is good. For example, we can look at what tools we would expect to be called given a question. Were those tools called correctly? Were the input parameters good? And finally, was the answer that was given correct and related to the question that was asked? So being able to break apart the full journey and provide individual assessments of bits of each of those traces allows us to gain confidence in the whole of a complex agentic system. User feedback is pivotal to this. So we only know how well we are doing against our evals. We have online monitoring, which is giving us additional feedback. But the other place that we get really, really good feedback is when a user is able to say, this was good or this was bad. So for us, two agents that run through Slack, so that's the insights and the shift agent, we have, after a response, a thumbs up, thumbs down icon. User clicks on that, that brings a pop-up which asks them to give more information. Some responders do, some don't. That information is then passed into our backend where we have the span ID of that response. We can then upload that feedback into Arise where it's linked to the span ID and that agent response. And we can then pull those out and look at those individual traces. So currently, we're able to use those individual human responses to really identify areas where it's performing badly or it's performing well and build out our data sets from that. We find this particularly useful during internal testing, where you want to run multiple different queries, different responses, and see how something is going and see how that's looking. So internal testers, having them have a single place where they can ask a question, give a response, and do an end-to-end test of everything. Some parts of, often with multiple agents, and some non-agent parts of this. Some of our responses do not even go to an agent. They're picked up and answered deterministically. Being able to combine that full chain and add a human annotation to it quickly and easily has proven invaluable. So agent engineering has been an interesting journey over the last year, really, in PagerDuty. There are two types of agent engineers, I'd say, in PagerDuty, none of whom are actually defined as agent engineers, but they're people who've drifted into that role. There's people like myself. I started off as a data scientist, became a machine learning engineer, and am now fulfilling the role of an agent engineer. Or there's people who've come from more of a software engineering background and come across to agent engineering. And we bring different strengths and weaknesses, but there are a few things we have to have in common. From more of a data science side, we've got to be comfortable with ambiguity and non-determinism. We've got to be used to the fact that if you rerun the same thing twice, you will not get the same answer. So how do you manage that? How do you produce evals against that? How do you know something is doing well? And how do you get something better where it really is it's a bit of an art rather than a science to improve a prompt or to improve an agent? From the other side, the software engineering is very useful as well. Agents are long-running processes, often involving multiple different calls across the whole of PagerDuty. We have a lot more east-west communication going on within our agents than we do in a lot of our other systems. So having good, rigorous software engineering has been crucial to building out our AI agents. This combination of skill sets, there aren't many people who have all of that capability in one place. So we found it's become more of a team game. And that team has formed the core of the company from agent engineering point of view. But we're not the people who are going to be building all of the agents. We take the view that agent engineers should be a bit like database reliability engineers. They're the internal subject matter experts. They're the ones who are worrying about the thorniest problems or providing the standard tooling that everybody else can use. The majority of the agent development within PagerDuty is being done by the standard software engineers. So we're not expecting them to know the subtleties of the current frameworks or how best to handle synchronous and asynchronous Redis locks or any of the other complexities that come from building out an agent in production, especially at scale. But we're expecting them to be able to use the tooling we provide and build and construct the agents from that. I think for me, the most important thing and understanding what you want your agent to do and building out your critical user journeys. Once you've got your critical user journeys, you need to turn that into a set of evals. And that comes from talking with your product team and defining your criteria. So those evals need to include quality metrics, they need to inform latency metrics, they need to include cost metrics. Once we have those, you have something you can build against. You can work a bit on what kind of models you want to use, what kind of structure you want to go with. That allows us to shape what we want and build it ourselves. The challenge is, though, that you're often dealing with people who aren't used to building agents and aren't used to non-deterministic systems. They'll come in with questions such as, why is a performance of 95% not attainable? Why is performance of 99.9% not attainable? Humans always do these things perfectly. Why can't the agent? So what I would seek to avoid is over-promising on performance metrics early on and working with the people you're delivering to that 95% performance on some complex tasks is better than human performance on those tasks. Or 95% performance on complex tasks within 30 seconds, but then you can keep iterating and learning and improving, maybe is better than humans could do or is providing a significant value. So it's understanding what you want the agent to do and what the value is, and working with colleagues across the business to develop and understand those metrics that I think are most important. The biggest benefit we've seen is it has opened up the black box of what an agent is. Prior to bringing in an observability platform, we were working with LLMs, and for a simple LLM chain, you can see question, response, question, response, question, response, working along the chain. That worked very effectively. With an agent, where you don't have a simple chain, you don't have something constructed, you need to have another way to see the inner workings of the agent, what it's doing, what it's thinking, where it's getting things right, where it's getting things wrong, and where it's getting stuck in loops. And that, for me, is where observability has really opened up that thinking, that process, and allowed us to identify the problems earlier and much, much, much easier than we were before we started working with an observability tool. So for us, when we were going through our procurement process, we wanted a tool that would make it easier for us to develop generative AI solutions. At the time, it was broad Gen AI, and an agent started coming on. And we really started going, okay, how do we open up this black box? Arise provides that. Its tracing is best in class. We can see exactly what's going on. What Arise brings that we didn't find in any other tooling out there was the ability to run online metrics. So it's not just tracing, it's the ability to evaluate how your agent is performing in real time, use those evaluations and turn those into PagerDuty alerts if needed. If the performance degrades, we need to know about it, and we need to know about it now. We can't wait until tomorrow when we see, oh, this isn't going right. Oh, what's going off a bit wrong on that metric that's nothing to do with a standard agent metric. And then we have to run our test script. And then we see, actually, we've been running for several hours with a problem, or with someone performing an attack against us, or some other reason that we need to have agents on keyboard. No, sorry, not agents, but some other reason we need to have engineers on keyboard now fixing that problem. So that real-time online evaluation and monitoring has been crucial to us as we've looked to develop our agents.